Hello, welcome to The Extraordinary, where we are committed to the relentless pursuit of excellence. Over here, we love to learn new things, we love to skill up, and if that's something that you are interested in, do subscribe to the channel and click the bell icon. Let's get into the topic of today. So, we're going over Python classes, and before we get into it, there is a long text here basically explaining a few things that we need to know. I've done a summary so you don't have to go over this long text. So let's go over it together. A word about names and objects. Multiple names in multiple scopes can be bound to the same object. This is known as aliasing in other languages. Aliases behave like pointers in some respects. Passing an object is cheap since only a pointer is passed by the implementation, and if a function modifies an object passed as an argument, the caller would see the change. So this makes it very performant for Python to be able to pass objects as arguments to functions. Python scopes and namespaces. A namespace is a mapping from names to objects. There is absolutely no relation between names in different namespaces. That means two modules may both define the same function called maximize without confusion. Users of the modules must prefix it with the module name. For example, you could have draw.maximize, or screen.maximize. So you see that we have maximize function in two modules, but there is no confusion between the two of them because they exist in different namespaces, which is the modules. All attributes in a module share the same namespace. Attributes may be read-only or writable. Writable attributes can be assigned to a value. For example, modname.theanswer equal to 42. So 42 is being assigned to the attribute the answer on the module modname. Just correct that. Writable attributes may also be deleted with the del statement. For example, we could say del modname.theanswer, which is going to delete the answer attribute from the module modname. Namespaces are created at different moments and have different lifestyles. The namespace containing the built-in names is created when the Python interpreter starts up and it's never deleted. The global namespace for a module is created when a module definition is read in and normally lasts until the interpreter quits. The local namespace for a module is created when the function is called and deleted when the function returns or raises an exception that's not handled within the function. A scope is a textual region of a Python program where a namespace is directly accessible. There are 3 or 4 nested scopes whose namespaces are directly accessible during execution. The first one is the innermost scope, which is searched first, which contains the local names. The second one is the scopes of any enclosing functions, which are searched starting with the nearest enclosing scope containing non-local and also non-global names. The third one is the next to last scope, which contains the current module's global names. The last one is the outermost scope, which is search last and is the namespace containing the built-in names. Let me update this. The global namespace, the global statement can be used to indicate that particular variables live in the global scope and should be rebound there. The non-local statement indicates that particular variables live in an enclosing scope and should be rebound there. So all these things that we've just talked about is basically explained in more detail in this document, but we're going to be seeing them as we go along in the examples that we are looking at for Python classes. Let's just look at a quick example for scopes and namespaces. I'll create a new file here. I'll call it example1.py. Then I'll write this. So now that we've written this example, let's run it, see what we get. Yeah, we'll get the results. Here is, sorry, I made a mistake here. Correct that. Good. Now we have the results. So what is happening here? The first thing that we have here is we define an outer function called scope test. And then inside that function, we are defining doLocal, which assigns local spam to a spam variable. We also define doNonLocal, which assigns non-local spam to a spam variable. But before that, we have this non-local spam statement, and I'll explain what this is doing in a moment. Then next we have the doGlobal function, which also assigns a global spam here to a spam variable, and we'll have the global spam statement. Then next we assign test spam to a spam variable. We call the doLocal function. We'll print this text to screen. We call the doNonLocal function, print this text to screen. Call the doGlobal function, print this text to screen. All this is happening in the scope test function, which is called onLine21. After which we print in global scope and we print this spam to screen. Now, the technical details of this is at the beginning, which is where we start with this scope function, scope test function. Inside the scope test function, we are defining spam to be equal to test spam. Then we call doLocal function, which is supposed to overwrite the value of spam, but it wouldn't do that. Why? Because this spam variable here creates a local scope inside this doLocal function. As such, the outer spam variable is left intact. That's why after we call this doLocal and then we print after local statement and spam, we still get test spam as the value, which is the value that was defined here. Then we call doNonLocal. Now inside doNonLocal function, we write this non-local spam statement, and what this does is that it makes the spam variable a non-local variable, which means that when we assign non-local spam string here to this spam variable, we are now overwriting this variable, this outer variable here. When we print after non-local assignment string here, the value of spam of the spam variable would no longer be test spam, it will now be non-local spam. Okay, and after that we do global. Inside the doGlobal function, we wrote this global spam statement on line 10. What this does is it creates a spam variable in the global scope, and we assign this global spam string to that variable. But because that variable is in the global scope, it does not have anything to do with this test spam variable. So the value of the test spam variable still remains what was set by this doNonLocal function, and that is why after the global assignment we still get non-local spam as the result. Then finally, when we come out of the scope test function, we run print in global scope, and the variable of the spam will be the value of the global spam, and that would be global spam. Sorry, this is not correct. I made a mistake earlier, so let me run it again, and we get the correct value, global span, which is based on what we did in this global function here, where we set the variable to be a global variable, and then we set the value of that variable to be global span. Now, don't worry if this looks a little bit confusing right now. Like I said, as we continue to do more examples, it will become clearer and clearer. But that's it for this episode. If you enjoyed the content, remember to like and subscribe, and make sure you share with others. And I'll see you in the next one. Bye.